Hi everyone. So today we will solve walking robot simulation part 2. Yesterday we have solved walking robot simulation part 1. If you have not seen that video, I will paste the link in the description. You can check that. So for this problem, it is given in the description that a width cross height grid is on a XY plane with the bottom left cell at 0, 0 and the top right cell at width -1, height -1. The grid is aligned with the four cardinal direction north, east, south, and west. A robot is initially at cell 0, 0 facing direction east. The robot can be instructed to move for a specific number of steps. For each step, it does the following. So what are the operations it will do? The first operation is attempt to move forward one cell in the direction it is facing. If the cell the robot is moving is out of bound, like if we have given the width into height, so if the width is still here only and height is still here, so this will be our grid. If we are at this cell and we can't move forward, like it is out of bound, then what we need to do is like we need to turn 90-degree counterclockwise. In that case, we will move counterclockwise 90 degree. If we will be at this position, then we will move to this. If we will be at this, then we will move this. If we will be at this position, we will move at this direction. Then, after the robot finishes moving the number of steps required, it stops and awaits the next instruction. If our all steps are done, which is given in the previous instruction, then we will move with our next instructions. And implement the robot class. So this is we need to implement some methods. So robot class, this is just to initialize the variables. So in this width and height is given, initialize the width cross height grid with the robot at 0, 0 facing east. And it is also given that robot will start from 0, 0 cell and that robot is facing east. Like if first instruction will come to move some points, then it will move towards east. And the second is like second method is step. इसमें क्या करना है? We need to instruct the robot to move forward num step. Okay, this is step is to make a robot move forward num step, and this get position to return the current position of the robot, and this get direction to return the current direction of the robot. So yeah, that's it. And if we'll explain through this example. So what is given in the example is like सबसे पहले is the robot. So we will initialize our that width and height. So width will be 6 and height will be 3. If width is 6, then the maximum x direction it can move is still 6 minus 1, because width minus 1. It is starting from 0, 0, so it will move till width minus 1, 0. So maximum x will be 5. If we will talk about the maximum y direction, so it will move to 3 minus 1, because height is 3, so it will be 2. So if you can see here also, the maximum is 5, and in the height maximum is 2. So we will initialize this length and height and width. Then the next method is step. Step means 2 steps. So it is at this 0, 0. If it will move 2 steps forward, then it will go here. Then again step, and this is also 2. So again it will move forward 2 steps. So it will go here. And get position. We need to get the position. So the current position is at this place. The current position is 4, 0, because the x is 4 and the 0 y is the 0. So we will return this 4, 0. Then the get direction. So since we have not changed the direction, and from starting the direction is east only, so it will be now also east only. So we can return east. Then step. In steps, we need to again move 2 steps, but since there are like no place after this to one step we will move here, but for one other step it will go out of bounds, so we will change our direction 90-degree counterclockwise. So we will change the direction this time. So one it will move here, then one it will move here, so it will be at this place. Then again step, and it is 1, so again it will move 1, so it is at this position. Then again step, it will move 4, but there is nothing. If it will move forward, it will be out of bounds, so it will again rotate 90-degree counterclockwise. So now the direction will be, this is north, and now the direction is west. And from here it will move 4 to 1, 2, 3, 4. So it will be at this place. We need to get the position. So at this place the position is 1, 2. 1 is the x, and 2 is the y coordinate. And get direction, which direction the robot is at currently. It is on west direction, so we can return west. So yeah, this is like an easy question only, but here if we will see one thing, like if we will talk about this 0, 0 is the initial point, and this is something like if we will draw the grid, then we can notice one thing. Our num value will start from 1 to 10 to the power 5, but our height and width will be 100 only. Maximum it can reach till 100. So अगर अपन इस का पूरे का length if we will try to find, like if the robot will start from this 0, 0, and what if it will traverse the whole grid and it will again come to 0, 0, then what will be the length in this case, or we can say parameter. So अगर यहाँ पे parameter of this grid अगर अपन find करते हैं, then what will be the parameter of the grid? Parameter of the grid is 2 into height plus width. Height is this length, width is this length. But if you can see if it will, we can see with the help of this example also, if it will start from this and this height, this is the width 2 times and 2 times height. But if we are taking this height and width, then you can see this corner one is counting twice. Like if we will take this width and this height, we need to take, then this corner one elements are counting twice. So we can what will be the parameter? 2 into height plus width minus 4. Minus 4 is like because these corners are counting twice. So this will be our parameter. If we will try to find the maximum parameter possible, तो parameter की value क्या होगा? 2 into maximum height and width can go till 100. So it will be 200 minus 4. So parameter will be 400 minus 4. So it will be 396. Maximum parameter can go till 396. But our num value can go till 10 to the power 5. Num value is like much greater than this parameter. So what we can do is like when we have the step method and we have given the num parameter in that. So what we can do is like we can try to find the minimum num possible. Num will be equals to num modulo parameter. Because what if num value will be greater than parameter, तो क्या होगा कि the robot will start from this, suppose from this index, and after one circle, it will again come to this position only. So, like, why to waste our time complexity traversing that much? Simply, if we will do num equals to num modulo p, so it will automatically get this position. We will get this position, and we don't need to traverse whole circle. So yeah, that's it. And in this question, we only need to know about few things. Like first is the parameter. Parameter of this grid will be 2 into height plus width minus 4. And the second thing is like robot is starting from the 0, 0 cell. And the first direction will be east. So we can denote it with dir 0. So this will be east. So 1 will denote north. 2 will denote west, and 3 will denote south. So what the third condition we need to see in this case कि अगर अपना जो what if अगर if there is some value of num, so that if the robot is starting from the 0, 0 cell after traversing num distance, which is equals to parameter, it will again come to this place. But in our case, what we are doing, we are doing num equals to num modulo p. तो उस केस में if num equals to p or 2p, 3p something, so we will not get reminder in this case. So in this case, we will get num equals to 0. Num equals to 0 means it will return back to its position. So if it is at some other index, it is fine. But if it is at 0, 0, because our initial direction is east, but we already traverse, but we are not able to see the direction in this case because we are doing modulo. So what we will do is like if num modulo p will come as 0, like our final num will come as 0, and the robot is at 0, 0 index, like coordinate, like it is at the origin. So what we will do is like in this case we will make a direction equals to 3. 3 means south. The direction will not be east, it will be south because it came uh, after moving to hold this grid borders. So it will be again at 0, 0, but its direction will be south. Hopefully you got this. And if we will move to the solution. So in the solution, what is given? Like I have mentioned this width and height. The robot is starting from x is equals to 0 and y equals to 0. Initially, the direction is 0. 0 means initially it is at east. The direction will be east. 0 is denoting east, and north we will denote it with 1. And then west we will denote it with 2. Then south we will denote with 3. So robot, this function is basically just to initialize our height and width to w equals to width and h equals to height. This is just to make this height and width reachable to other methods. We have declared this w and h. And parameter we will find 2 into height plus width minus 4. I have already mentioned why we have written this minus 4 because the borders we are counting twice. So minus 4 we will deduct from this. Then coming to the step method, what we will do is a num step method, and inside the parameter is num. Num means we need to move forward num step. But what if the out of bound will come, then we need to move 90-degree counterclockwise, and then we will complete our remaining steps. So यहाँ पे हमने सबसे पहले we have done num equals to num modulo parameter. I have already discussed in the previous example that why we are doing this modulo parameter. क्योंकि अगर parameter value can be 10 till 10 to the power 5. Sorry, num value can be equals to 10 to the power 5, but our parameter value will be maximum till 956 only. So like why to traverse this whole grid again and again? We can simply get the minimum num we need to traverse by using this formula num equals to num modulo parameter. अगर अपना if after this doing modulo, if our num will come 0 and x and y is not equals to origin, if it is not equals to origin, then we are fine. Like if it is some other x and y, it is fine. But what we can return directly, and because num is 0, we already traverse num distance, so we don't need to do anything, and we can return directly if num equals to 0. Like our suppose this num value is 2 into parameter or 3 into parameter, some value is there, and we got num equals to 0, and we are at 0, 0. That means we are at this cell. But initially our direction is east. But now after doing this modulo equals to p, so we are not actually traversing the grid. But we know कि if we are doing this modulo, then like the robot is already done its traversal to this round grid. So what we need to check कि अगर if the robot is at 0, 0 after doing this modulo, then we need to change its direction. Its direction, because initial direction is east, but if it traverses, then अगर 0, 0 पे if it comes after traversing, the direction will be south. So direction equals to 3 because 3 is denoting the south, and we can return it directly. If it is not num equals to 0, if it is not the case, then what we will do is like we will do while num greater than equals to 0. If num greater than equals to 0, then if the direction is east, what we will do is like we will calculate minimum moves we need to do in this direction. So what will be the minimum moves? Because it will be num. Num is the like total number of moves we need to traverse into w minus 1 minus x. If x is this somewhere and this is w minus 1. So the distance of this between these two is w minus 1 minus x. So minimum of this w minus 1 minus x, and now we will get the moves it will do in this like east direction. So we will get the move, then we will add into our x. Then now we can minus equals to moves because we will deduct this moves from num. And if num is still greater than 0, like num is greater than 0 means if this w minus 1 minus x value is less than num, so now minimum we will get this, and if we will get minimum this, and we will deduct this moves from the num, so we are still left with some num value. So in this case, we will change our direction. We will move counterclockwise 90 degree, and direction will be dir1. dir1 is showing the north direction. Same we will do with dir equals to 1 means it is the north direction. So we will calculate the minimum moves will be num comma h minus 1 minus y, because some y will be there, then and this maximum point is h minus y, so this distance will be h minus 1 minus y. We will calculate minimum of num and h minus 1 minus y, and same we will add in this y, and we will deduct from this num. And if our num is still left, then we can change our direction, and now the direction will be west. Now we will check this. If our direction equals to west, if the direction is west, then what we need to do is like we need to calculate the minimum possible distance in this west direction. So we are at some x comma y. So this distance, the maximum distance it can move in west direction will be x only, because this distance is x. So minimum of num comma x, and x minus equals to moves, so it will detect x from the moves and deduct, because it is that our x value is reducing because we are going in the west direction. In this direction, when we are going, our x value we are adding, but in this direction we are reducing our x value. X minus equals to move, and num minus equals to moves, because num will be the total moves we need to take. But the move we need to take in the west direction is moves, so num minus equals to moves. And if still the num is left, then we will again change the direction, and same thing we will do with the this south direction. And if after traversing in this, if still the num will be left, then we will again change our direction, and we will change our direction to east again. In the get position, we need to directly return our x comma y. And get direction is simple, like direction 0 we are denoting with east, 1 we are denoting with north, 2 we are denoting with east, west. And if it is not 0, 1 and 2, then it will obviously will be south only. Direction will obviously will be 3, and we can simply see that it will be south only. We can return south. So yeah, that's it for this solution. Thank you.